That is the problem. Okay. And that happens immediately after element 524,244. Oh, wait a minute. Yeah, it's way easier. It's kind of the same as the last bug. Element is just jumping like crazy. So this should go from elements. Well, the element should be incremented by 1, and I guess this is then the last value. Because now all the pieces are in the far bottom right corner of their respective block corresponding to partition 0. That is, the white king and the black king are here because their block is this big. Oops. So they are in the bottom right as well. Therefore, the next element should be partition 1 and then element 0 again. But instead you go from here to there. That is the problem here. So what I should test instead is starting with this element and then looking what the increment operator is doing. I think you can just begin there. I expected it to take an int, but it doesn't. No, of course it doesn't, because it takes an info index, which means that that doesn't work since info index is an explicit constructor. Can't make this an unsigned long here. No, it will compile. Totally will compile now. Yes. Okay, and then we'll run it in the debugger, I suppose. Just to break 66 still. How can that take so long? It's the very first thing. Oh, it first has to calculate stuff before that. Oh no. Oh no. And I'm in debug mode. Yeah, that won't work. That's gonna take way too long. I think I don't need a classification. That's way faster, isn't it? Okay, so the current partition is 0. I really have to. Okay. Yeah. I ran into this so often that now I'm going to change it before I even continue. I didn't read it, quite obviously didn't read it. Yes, current partition is 0 and this is, well, that big value. And all that works. It's now printing them in the bottom right corner of the small block for the kings and the whole board for the rook. And then we do stuff, which, yeah, this is going to be non-legal, I suppose. So we do continue. And now I want to do this increment here. If I do a step, it's going to check I end. Now this is 0, and obviously I end is larger. I can even print this. Does not print. Stupid debugger. Let's just do a step. Oh, we're already in the increment. Of course, it's first going to increment and then do the test. Index. Can the x-coordinate of the rook still be incremented? No, because the rook is completely on the right. In fact, this should be equal to a rook limit. So yeah, that's 20, starting at 0. Rook limit is also 20. That is not the case. Now reset the x-coordinate to 0. And then we test, can we increment the y-coordinate? No, because the y-coordinate is 14. This is shifted, however, so we get some value much larger than that because it is shifted by, don't look. It's just shifted by 5 bits, yeah, obviously, right? No, just kidding. But this is also pre-shifted, so this is also 448. And therefore it's not less than, and therefore we're going to reset it with that same mask. And then we get the same question for the white king. Now the white king is also at its maximum value. So these two should be equal. And they are. Next, reset the white king x-coordinate. And also the y-coordinate is at the maximum. to reset that as well. What you're now left with is the blocking coordinate. It's about time I test that maybe. So T for binary, obviously. T binary, I mean, binary has lots of T's. Okay, so do I want to print index? Well, the mask is maybe interesting. Yeah, so the blocking has has 2 bits because the width here is 0, 1 or 2. That doesn't fit in 1 bit, 3 different values. The 2 takes 2 bits. And those 2 bits are stored in those 2 bits. And it is at its maximum, I mean, so this should print 1, 0 there. It would be nice if it was aligned, but I'm going to assume that this one is aligned with that one. Now I can just print yes, so this is 2. And the limit here should also be 2. That's the same as that one, so yeah. Great, so indeed we cannot increment the x-coordinate of the blocking. Therefore, reset it. And then we should have a y-coordinate left still. The y-coordinate uses 3 bits. Which are both there, or both these two. Because the height here is 0, 1, 2, 3, 4. The 4 doesn't fit in 3 bits. That actually totally fits in 3 bits. That's why it is 3 bits. It doesn't fit in 2 bits, I mean. Therefore, this should be four. Yeah, so using the mask, it's 4. It is correct because the y-coordinate of the blocking is 4. And the limit is the same value. So indeed, this says we cannot increment the block y-coordinate. And therefore we leave it the way it is. And we set index, no, we don't leave it the way it is. We set index to end. I think this is where it goes wrong. The question now is this the correct value for end? Because suspiciously look like exactly the value that we get. What am I trying to increment? Yeah, so this end has the wrong value, I guess. What is n then? What should n be, rather? Okay. accepted step. I really need this value now. Maybe we'll get there with a step. So this is that value. This is what you just assigned to it. What? 0. What is maybe the partition? Yeah. Never mind. Step. I guess this is end. I end returns n. Yeah, okay. So this is the value that I should have used. What might that consist of? Yeah, it's n. So let's just look here. N is the size of the array. Well, it should be able to find out what the bloody size of the array is. That is the black to move partition, some black to move partition element. Which is defined, yeah, what? Help. Ah, this is a local variable, probably. So let's have a look here. Is a reference to whatever black to move partition function returns of the graph. So, okay. This function that returns black to move, which is a partition type, which is an array of info nodes type. Thus, an element of this, I mean, that would be an info nodes type. I was pausing because we are looking for an array, and I thought that nodes type here is a vector, but no, it's also an array. So info has a nodes type. Yeah, it's also an array. Great. Now here we have the size, partition number of elements, which is calculated as 1 more than the largest value that will ever be stored in an info index. I create a partition element with all limit values, and indeed we did not go beyond the limit, so that's where it runs to. And then the black king square is constructed from block limits, the white king as well, and the rook from the board limits. think it is probably correct. You can then cast that to an info index, and which is just a wrapper, so that it is provided. And then get value to get the size type, and then we can add one, and that's the number of elements, and I agree with it. Let's look at square. Let me have a quick look at the square compact is constructed. It's just a wrapper around the coordinates type. We do that. Construct it directly. Could also pass X and Y, I suppose. Then this would be used. And then you have also an OR, the OR with X, and the Y is the OR between X and Y, where the Y is shifted. This is our 5, the 32 that we had before. But the problem with this is that then the Y cannot be pre-shifted, the Y that you pass to it. So I could then we cannot use limit Y, because the limit Y is pre-shifted. So I might as well take the limit and do the OR here instead of passing X and Y. Although it's sort of code duplication, right? I mean, this OR now duplicates the OR in the member function of square compact. Yeah, but it's correct, so I'm gonna leave it like that. So what I really need to use is then partition number of elements for end. So somewhere I had end. Here, which is in partition element.h. And I thought I could do that like this, but it's apparently not good. Yeah, that's just, I don't know. I don't need to know why it is not good. It's just not good. Yeah, the number of elements is a size type, and we can construct an info index from a size type. I would rather actually construct it instead of using copy construction. And now it should work. Except that it doesn't even compile, because it has no clue what partition is in this file. Partition element. Partition element does not know anything about partition, and I probably cannot include it, because I have the feeling that partition element is going to include partition or not. Wait a minute, the other way around. Partition.h. Yeah, partition.h includes partition element.h. So we have a circular header problem. The number of elements here is calculated in partition. I could just move this to a partition element, I guess, because otherwise, nah. It feels like it belongs here, because a partition has this many elements. Why do I need in partition element that? Oh, because of the end. Yeah. I think my food is running. I'm gonna have to stop here. I'll be back after dinner.